So we've been doing operations on rational expressions. At this point, we're going to bring all of that together, and we're going to start by doing it with complex fractions. Complex fractions means fractions within fractions. Okay, so we don't mean that we're including complex numbers, we're just saying that these fractions are more complicated. And essentially what we're doing here is we're getting rid of these fractions within fractions and simplifying what this looks like. Okay, so we've done this before. You've seen it before in simple form when we were talking about division of fractions. One of the ways that we can write it is like this, the 3/4 divided by 2/3. And we said in order for us to simplify this, we want to get rid of the fraction in the denominator, because then we're only going to wind up with one fraction instead of two fractions, one in the denominator and one in the numerator here. Okay, so in order to do that, we multiply the bottom by the reciprocal, by its reciprocal. So the reciprocal of 2/3 is 3/2. And the whole point of multiplying by the 3/2 is so that we cancel out that bottom piece. But because we don't want to change the value of the fraction, we can't just multiply the bottom by 3/2. We have to multiply the top by 3/2 also. Okay. And now we have this one fraction. We have a fraction times a fraction. We multiply the numerators. We multiply the denominators. And this gives us 9/8. And 9/8 can't be simplified, so this would be the end of it. Okay. So now we're going to add to this a little bit, and we're going to say, okay, well, now we're not just dividing or just multiplying. We're going to add some addition or subtraction in there as well. So let's take an example. Again, we'll just use numbers to start with. So let's say that we have 2 plus 5/6, and then 1 minus 7/8. And you can see from here why we say that at this point we're combining everything that we learned, because we have fractions within fractions, so we will be dividing and multiplying, but we're also adding and subtracting. And in order to do this, we can only have one fraction in the numerator and one fraction in the denominator. So that's our first goal, okay? Get one fraction in the numerator and one fraction in the denominator. And what that means is that we have to add these fractions here in the numerator, and we're going to subtract these fractions here in the denominator. So we're going to be doing the addition and the subtraction first, because remember there are invisible parentheses, so we can't work between the numerator and the denominator at this point. Okay, so in order to do that, we need to find a common denominator. So the common denominator between this is a 2/1. We can write this as a 1/1. So write your whole numbers as fractions to help you. And we're going to find a lowest common denominator, okay, which means a least common multiple of the two denominators. So this is a 1 and this is a 6. So what we can do is we can multiply this first fraction by 6/6, and that'll give both denominators a value of 6. And if we look down to the bottom, if we want to do two things at once, in order to do the bottom, we would multiply this first fraction by 8/8, because that second denominator is an 8. And this will make both denominators the same. Remember, we're multiplying by 8/8 because we really are multiplying by 1 here. So we're not changing the fact that this is a 1, okay? So what we get when we multiply this is we get a 12/6 plus 5/6. On top, 2 times 6 is 12. That's where we get this 12 from. And then 8/8 minus 7/8. And now we can combine these fractions. So we found a common denominator, and now we're ready to combine it so that we get one fraction in the numerator and one in the denominator. So 12 plus 5 is 17, so we get a 17/6. And 8 minus 7 is 1. So we get a 1 over 8. Okay. And at this point, we have a fraction over a fraction. So we can do exactly what we did up here and multiply the bottom by the reciprocal and the top by the reciprocal of the bottom. So we're going to multiply the bottom by 8 over 1 because that's its reciprocal. The 8's will cancel, the 1's will cancel. And we have to do exactly the same thing on top. Okay. Now we can multiply 17 times 8 over 6 at this point and then reduce. Okay. For some of you who are more accustomed to reducing here, you can. It might make your multiplication a little bit easier, right? So this is just like when we reduced with rational expressions where we canceled things out before we multiplied. That's what's happening here. 6 and 8 are both divisible by 2. So we could divide both of these by 2, and this is a 3 and this becomes a 4. So we're saying 6 and 8 are both divisible by 2. That's how we're getting that 3 and 4. And now what that means is that what we really have is 17 over 3 times 4 over 1. We can't reduce anymore. 17 times 4 is 68. So we have 68 over 3 as our final answer. Now, if you didn't reduce here, okay, then you would have had 136 as your 136 as your numerator and 6 as your denominator, and you would have been able to divide both of those by 2. So you just would have gotten larger numbers if you didn't reduce here. If you didn't divide the 6 by 2 and the 8 by 2, you had done 17 times 8 over 6 times 1, and that would have given you 136 divided by 6. And getting that, you would have been able to divide both the top and the bottom by 2 at that point. How you do it is up to you. Okay, so let's just review what we did here. I will put this in blue. So the first thing that we did is we found a common denominator. For the numerator. And we found a common denominator for the denominator. So we did this separately. That was our first step. Our second step was to combine fractions in the numerator. Combine meaning add or subtract. And in the denominator. And then now we have one fraction in the numerator and one fraction in the denominator. So this is important here. The result of this is one fraction. In the numerator. And one fraction in the denominator. That's ultimately what you want, because that's when you can do this last step of multiplying by the reciprocal of the denominator. Sorry, this should be denominator. Okay, so our last step is to multiply the numerator by the reciprocal of the denominator. So it's the same 3 steps, okay? You're combining the numerator, combine the denominator by finding a common denominator, by finding common denominators. So you're doing addition and subtraction first. Then you're going to multiply by the reciprocal of the denominator. So what we're doing is we're saying multiply the numerator by the reciprocal of the denominator. The denominator just disappears here, okay? So again, this is just like expressions, okay? And then, as always, reduce your final answer if possible, okay? Okay, so this is with numbers. Now let's take an example with expressions. So let's say that we have 1. I'm leaving some extra space here because I know that I'm going to have to find a common denominator here. So we have 1 plus 1 over x plus 3, and then we have 1 plus 7 over x minus 3. And you can actually work with the numerator and the denominator simultaneously, okay? It's up to you. You can do it separately or you can do it together. I'm going to do it together here. So again, it might be helpful to write this 1 as 1 over 1. And same thing with the bottom one here also. Write it as 1 over 1. Just because a whole number, if you have it as a fraction, you want to make sure that you remember that the denominator is 1. And this could help you remember that. Okay. So we're going to look for common denominator. Again, remember you're asking yourself, what does the other denominator have that this one doesn't? The other denominator has an x plus 3. So that's what we're going to multiply by. X plus 3 over x plus 3. And this denominator, we don't have to multiply by anything because in the other denominator we have a 1 and we don't need to multiply by 1. It doesn't change anything. Okay. And then the same thing down here. The only difference is that the first fraction you're multiplying by x minus 3 over x minus 3. So what that gives us, and I'm going to write this as an extra fraction, okay? So you could conceivably skip this step. We have x plus 3 over x plus 3 plus 1 over x plus 3. And then in the bottom here, we have x minus 3 over x minus 3. And then plus 7. Over x minus 3. So now is the point where we combine the numerator and we combine the denominator. So x plus 3 plus 1, remember you're only adding the numerators. The bottoms here are the sizes of the piece. The tops, the numerators, are the number of pieces that are being added. So we add at the top. That should be familiar from the last lecture. So we get x plus 4 over x plus 3 on top. And on bottom, we get x plus 4 over x minus 3. Okay, so we found a common denominator. Then we combined the fractions. And now we're going to take the numerator and multiply by the reciprocal of the denominator. So we have x plus 4 over x plus 3 times x minus 3 over x plus 4. Okay, and some of you are going to notice we can automatically cancel that x plus 4. Remember what's going on here? Okay, we're extending this line. And all of these have invisible parentheses around them. So the x plus 4s will actually cancel. And what that leaves us with is just an x minus 3 over an x plus 3. And there is no relationship between x minus 3 and x plus 3. So that is our final answer. There is nothing that can cancel. Okay, we have invisible parentheses around here, so the x minus 3 is together. The x plus 3 is together, so nothing can be canceled from there. Okay, so again, we found a common denominator. This is like step 1. We found the common denominator. This is step 2. We combined the fractions. And this is step 3. Okay, so here all we did is we multiplied to actually make this one fraction. So we multiplied the 1 over 1 times x plus 3 over x plus 3. That's how we got this. And then we multiplied 1 over 1 times x minus 3 over x minus 3. And that's how we got this piece right here. So we have our 3 steps, 1, 2, and 3. In step 3, when you multiply, you're simultaneously reducing. So the x plus 4 over x plus 4 canceled. And that's how we got x minus 3 over x plus 3. Let's take another example of a complex fraction. So let's say, for example, that we have 3x plus 1 over x squared minus 49. And then we have 9x squared minus 1 over x minus 7. And here this is a little bit different, and the reason why it's a little bit different is because we don't have to add or subtract fractions. We have one fraction in the numerator and one fraction in the denominator. But if you remember from division, one of the things that we want to do is we want to factor. We always want to factor. So we can do that here. We have 3x plus 1. And x squared minus 49 is a difference of squares. It's x plus 7 times x minus 7. And we could factor here, or we could factor in the next step. Okay, so we could switch this step with the next one. That would be fine. Now 9x squared minus 1 is also a difference of squares, so that can also be factored as 3x plus 1 over 3x minus 1 over x minus 7. And this middle fraction bar, I like to just make a little bit longer so that it's really clear what the different fractions are. So just be aware of that. In fact, I'm even going to move this equal sign over a little bit. Okay, so we have this numerator, and here's our denominator. And then we're going to multiply by the reciprocal of the denominator. So we get 3x plus 1. And feel free to put that in parentheses. We're still keeping the fractions separate, so it's not necessary. But always feel free to put something in parentheses. Okay. And then we're going to multiply by the reciprocal of the denominator. So the reciprocal of the denominator is now x minus 7. Over 3x plus 1, 3x minus 1. Okay, and the idea of multiplying the numerator by the reciprocal of the denominator is that we multiplied by the reciprocal of the denominator on bottom too, but everything canceled. So because everything cancels, we can just ignore this whole bottom, and then what we do to the bottom, we have to do to the top. So this is just the top. It's saying we don't have to show it on bottom because we're always going to get 1. Okay. And now this is just a matter of reducing. So x minus 7, we have 1 on top and we have 1 on bottom. And 3x plus 1, we have 1 on top and we have 1 on bottom. So remember, when everything cancels in the numerator, we're left with a 1. Things that are in the denominator can't just move up to the numerator. Okay, we did that in exponents we could do that in exponents, but only if we're changing the exponent from positive to negative, and there would be no reason to do that. We never want to add in negative exponents. So this would be your final answer here. Okay, so let's just make sure that we're clear about what happened. The first thing that we did is we factored. Okay, both the x squared minus 49 and the 9x squared minus 1, both of these are differences of squares. So at this point, you should be really familiar with what differences of squares are. You should be making sure that you can recognize them easily, okay? And you should always be looking for them. So that's where the x plus 7 times x minus 7 came from, and that's where the 3x plus 1 times 3x minus 1 came from. Then from here, I'll slant it a little bit to here. We multiplied the numerator by the reciprocal of the denominator. And then from here to here, we just reduced. So this was a complex fraction where we actually saved a lot of time because we didn't have to do any addition or subtraction. We already had one fraction in the numerator and one fraction in the denominator. The purpose of factoring was to reduce, okay? We're just writing this down. We already had one fraction in the numerator and one in the denominator, so we didn't have to do any addition or subtraction. Let's take one more example of complex fractions. Okay, sorry, kind of ran out of room there. Let's take one more example. And this one, it's not any harder. It's just that we're going to put in an extra fraction in there. So let's say that we have, I'm leaving extra room on the side because I know that we're going to have to find common denominators. Let's say that we have 4 minus 1 over x squared. And then we're going to divide by 4 plus 4 over x plus 1 over x squared. So this is our original problem. I encourage you to pause the video, try this on your own, and then you can restart the video and see if you can do it on your own. Okay. So we're going to do the same thing. We have to combine the fractions in the numerator and combine the fractions in the denominator so that we have one fraction on top and one fraction on bottom. Okay, so in order to do this, we need a common denominator. It's helpful to take our, we'll put this in green. It's helpful to take our whole numbers and write them over 1. Just so that we don't forget that we have to multiply on top and on bottom. And we have 2 fractions, so we're going to say what is the other one half that this one doesn't. The other denominator has an x squared. This one doesn't. Notice we're only looking at the numerator. So we multiply by x squared over x squared. Now we can do the same thing with the denominator. We can say, what is the other fraction? What do the other fractions have that this one doesn't? Well, this one has an x and this one has an x squared. So we can actually just multiply by x squared, okay? Because the x squared includes this x here. So there's no reason to include this separately. So we're going to multiply this by x squared over x squared. And now we're going to go to this one and we're going to say, what do the other denominators have that this one doesn't? So this one now has an x squared. Originally it had a 1. You can look at the original. And if it has a 1, we don't have to do anything with it, okay? Because anything times 1 is itself. This one had an x squared. So this one isn't missing 2 x's, it's only missing 1 x. If we multiply by x over x, we're going to wind up with an x squared on bottom. Okay, so we don't have to multiply by x squared over x squared for this middle fraction. We can just multiply by x over x. Okay, so let's combine. Let's first multiply so that we get our fractions easily seen. Here we have a 4x squared over an x squared minus a 1 over an x squared. That's what our top looks like now. On our bottom, we have a 4x squared over x squared again, plus 4x over x squared, plus 1 over x squared. Okay, so now we can combine our fractions. So we're gonna, in the top, we subtract our numerators. In the bottom, we add our numerators. So we get 4x squared minus 1 over x squared. And on bottom, we get 4x squared plus 4x plus 1 over x squared. Okay, so now it's time to multiply by the reciprocal, okay? So again, this is like our step 1. Finding the common denominator. This is our step 2. Now we're ready for step 3. So step 3 is to multiply by the reciprocal. So we do 4x squared minus 1 over x squared, and we're going to multiply by x squared over 4x squared plus 4x plus 1. And this 4x squared plus 4x plus 1 is actually factorable. Okay, so I'm going to go through and I'm going to factor it here. I'll go through the steps with you. We multiply, so we're factoring. I'll do this in a totally separate color. This 4x squared plus 4x plus 1. So just to review with you, we multiply a times c, which gives us 4. Okay, this is our a times our c. Then we need two numbers that multiply to 4. And that add to 4. That's a 2 and a 2. So they have to multiply to our a times c, and they have to add to our b. Okay. Then if you remember, we rewrite our b term, our 4x, using this 2x and this 2x. So it becomes 4x squared plus 2x plus 2x plus 1. And from that first, this is factoring by grouping. So from these first two terms, we can factor out a 2x. So it becomes 2x times 2x plus 1. From the second set, we can't factor anything out, so it just becomes 1 times 2x plus 1. And if we pull out the 2x plus 1, we get a 2x plus 1 times a 2x plus 1. So if we combine this, okay, first of all, we can cancel out the x squares if we want to. So let's actually do that, just so that we could rewrite this as one fraction. So I'm putting in a couple of extra steps in here, but you can absolutely skip a couple of these steps. What this gave us was just a 4x squared minus 1 over that 4x squared plus 4x plus 1. But now we can factor. So factoring is the part of reducing, right? Our last step is to reduce. So to reduce this, we can factor the top is a difference of squares. We have 2x plus 1 times 2x minus 1. And then the bottom, we already factored to 2x plus 1 times 2x plus 1. And what happens is one of these 2x plus 1s cancels, which means we're left with 2x minus 1 over 2x plus 1. Okay, so this whole last part here, this whole section that you see here is an effort to reduce. That's what's going on in this whole section here. We wanted to make sure that we couldn't reduce, so in order to do that, we have to factor those quadratics. And when we factored those quadratics, we could in fact cancel out a 2x plus 1. Okay, we hadn't been able to do that previously when we were doing a lot of our division problems. And now 2x minus 1 over 2x plus 1 is our final answer. Okay, so keep in mind, it's going to be the same every single time, okay? We're going to be finding a common denominator, combining our fractions so that we have one fraction on top, one fraction on bottom. Once we have that, we can multiply by the reciprocal of the denominator. And then from there, it's reducing, which may require us to factor. So here we factored first, and then we multiplied by the reciprocal of the denominator. In this example on top, you could have multiplied by the reciprocal of the denominator first and then factored, which is what we did over here. So it's up to you, okay? You could reverse it. Both are perfectly acceptable. So that's one way to kind of combine everything that we've learned up to this point in rational expressions.